Welcome to the second video of stoichiometry. We're going to go ahead and jump straight into an example problem because the example problem will show you how most of the stoichiometry problems will work for a balanced chemical equation. So our first example is up on the screen already, and I went ahead and did it in a way where you have your balanced chemical equation is going to come from the wording that's given to you. And then you're going to work into the actual stoichiometry part. The big thing here is that you always need a balanced chemical equation, and I will tell you why once we write down our balanced chemical equation. So here we go. Our problem states ammonia reacts with oxygen, yielding nitrogen monoxide and water. How many grams of water are produced when 25.0 grams of ammonia reacts? So we have two different sentences here. The first one's going to allow us to set up our balanced chemical equation. When we have the wording as we do here, we just need to go back to our skills that we've already learned. How do we have common names for chemical compounds? How do we name ionic compounds? How do we name molecular compounds? And so you can have acids and bases in here as well, so that might also be something you want to brush up on. So give me a second, let's get the balanced chemical equation down here, and then we'll jump into the stoichiometry part. So now on your screen is the balanced chemical reaction for the first sentence that we read through of our example problem. So ammonia being NH3, oxygen's diatomic, so it has to be O2. Nitrogen monoxide is a covalent compound, so NO, we have no charge balancing there, and then water is H2O. One thing I do want to point out is if you do have an ionic compound that you need to go from the wording to the formula or the name to the formula, make sure that you're balancing your charges before you go ahead and balance the entire chemical equation. You can see here we already are balanced. If you need help with that, then you go back to the balancing chemical equation videos. So we're not going to review any of that, but everything on the reactant and product side should be balanced. To start out our stoichiometry, we need a balanced chemical equation, and I can't stress that enough. If, for instance, this would be not balanced, you may not get the correct answer. Most of the time that would be the case. Or say you balance this incorrectly, you also could get the wrong answer for stoichiometry too. The reason why are because our coefficients are actually the mole amount that we need for a chemical equation to occur. So you can see in front of NH3 or the ammonia you have a 4. That means we need 4 moles of ammonia for every 5 moles of oxygen for this reaction to proceed. So when we have the 4 moles of ammonia and 5 moles of oxygen reacting, we should be producing 4 moles of nitrogen monoxide and 6 moles of water. And we're going to use these molar ratios in our stoichiometry. So let's go ahead and reread our question. It says, how many grams of water are produced when 25.0 grams of ammonia react? So the first thing I suggest for students to do, and I'm going to switch colors so it kind of stands out a little bit more for us, is to actually write down where the 25.0 grams of ammonia should be on our balanced chemical reaction, and also put a question mark underneath the compound that you're actually working towards. So it would look something like this. We have 25 grams of ammonia, so I want to write that underneath it. And we're going to go to water, and we don't know what that amount's going to be. Visually, we can easily see what we're working towards and what we should be starting with. And that is going to really help us because, as you can see, we're not going to stay with one compound the whole time. We're going to switch over from ammonia to water here. And I'm about to show you how you go ahead and do that. So before, with our other stoichiometry video, we know that everything goes through moles. If you look at that diagram with the moles in the middle and the 3 branches off of it, we always have to go from one branch back to moles to go to another branch. And the same thing happens here. We always want to go through moles when we need to convert from one compound to another. So the first thing we're always going to do, if given grams, is to get to moles. And to represent that step, I'm going to start doing a box here. We want to go from grams to how many moles. we have of NH3 or ammonia. Then we can go ahead and convert from moles of ammonia to moles of water because of that molar ratio we talked about before. And I will reiterate that when we start setting up our problem. So here, we're going to go all the way across here and figure out how many moles of water we have within one step. And then we can go back from moles back to grams from the stoichiometry we've been learning. So we have an arrow that goes back up. And so this is going to be a 3-step problem because you have 1, 2, 3 arrows or 3 steps. Let's go ahead and go through each step. We're going to have to use dimensional analysis, a T-diagram. You might have learned it a couple different ways, and I'll set it up the way my class is learning right now. So whatever is given to you needs to be in the first box. So the 25.0 grams. I like to label it with what compound you're doing because that's going to help you keep track of where you are in your equation, especially since you're going to be converting from ammonia to water in one of your steps. So I have the 25.0 grams of NH3. That's my very first box for my dimensional analysis. And just to, reiterate, it's over 1. And so you can leave that blank. You can put an X there, a smiley face, but really that box is over 1. The next thing we need to do is go from grams to moles. And so we need the molecular weight of NH3. And I'm not going to go over what that is going to be in the video. So I'll just plug that in here. So now let's go ahead and plug in our molar mass for the ammonia. So since we have grams of ammonia on top, we want grams of ammonia on bottom, which is 17.04. And whenever you do a molar mass, remember it's always 1 mole. And so once you start doing these problems on your own, whenever you're doing them, a molar mass should always be so many grams per 1 mole. And that's going to be something I want you to focus on for this step and the other step that we are going to do here, where we have to do molar mass again. We want to go ahead and separate that off. So if we went ahead and did this step here, our grams of NH3 and grams of NH3 here would cross out. And so at this step, if we've solved it here, we would be in moles of ammonia. We want to go ahead and switch from moles of ammonia over to moles of water. And how we are going to go ahead and do that is we're needing to look at the coefficients, the 6 and the 4 here. And so since you have moles of ammonia on top, that's telling us we need moles of ammonia on the bottom. And the number that goes here is the number that is a coefficient. Okay, so we have a 4. And then at this point, the moles of ammonia would cancel out, cross out, excuse me. And so we need to go to moles of water. This is where the switch occurs in our math. Just like this 4, the moles of water will come from our equation up here, which is a 6. And so we'll have 6 over 4. That can reduce down, but don't worry about reducing it down unless if that's really something that's going to have like a pet peeve type of effect on you. You can simplify that down to 3 over 2. I just think it's easier to plug exactly what is in your coefficients for your reaction into that step. So the next thing we have to do is finish this up going from moles to grams. So we need the molecular weight of water, which I already have calculated here. And so since we have moles of water on top, molecular weight is always 1 mole, and this will be of water. The molar mass of this is 18.02 grams of water. So if we go ahead and go through this, cross out what we can, I can cross out grams of NH3. I can cross out moles of NH3, top and bottom. I have moles of water, and so my units are now in grams of water. And that is what the equation was looking for, or the question, should I say. So when we go ahead and multiply this out, divide at the very end, what I want to go ahead and do is do 25 times 1 times 6 times 18.02 and get an answer for that. 17.04 times 4 times 1, get an answer for that. and then you just divide those two answers. So let me go ahead and get an answer up there for you, and we'll talk about a few more little things that can change within your stoichiometry problems. But for the most part, it's going to stay pretty consistent here. Okay, so now you can see the answer in green kind of boxed in the middle of the screen, or about in the middle of your screen, of 39.7 grams of water. Because you started out with 3 significant figures, your answer should have 3 significant figures in it. And so I actually had to round up a 6 to a 7 with the correct rounding. So you should have 39.7 grams of water here if you went ahead and calculated through the dimensional analysis correctly. What I really want to point out at this step is you're going to have a ton of stoichiometry problems from grams to grams, so reactants to products. You also could do the opposite. Go and start at products, and instead of going from reactants to products, you can go from products back to reactants. So the problem could say something like, you obtain so much water, figure out how much ammonia that you need to get that amount of water. And so you just do exactly the same thing. Another thing that's going to spout off of this, or kind of lead on from this, is you know how to go from moles to molecules and atoms. So instead of going back to grams at the end, it could ask you how many atoms, how many molecules you have here. Another thing that's going to be thrown at you is, instead of starting at grams, you actually could start at moles. And so that actually ends up being an easier, or at least quicker, problem to do, because you don't have this step to do. However, it throws some students off because it's not the same consistency of the other problems that they're used to. So that's the next step to be doing. You have the general knowledge here. Again, you know how to do grams to moles and moles back to grams from our first video. So really the big thing here is realizing that you have the ratio between moles of one thing to moles of another thing when you have a balanced chemical reaction.